Welcome to Intro to Programming for March 4th. Today we are talking more about functions, specifically something called variable scope, which relates to functions. And then I will do some example programs so you can see how to do it if you're not following it yet. Okay, so far we've dealt with variables outside of functions, and so those would be at the file level or the module level. So we've created variables and we've just used them and we haven't thought too much about them. When we get to a function, that changes a bit because variables that are defined inside of a function or outside act differently or are used differently. And that's called the scope of a variable. Scope refers to the accessibility of a variable within a section of code. It basically means, can I use this variable? Can I access it? Okay. So if we look at the code in the notes here, I've got a couple of functions. It's very simple functions to add two numbers. And I've defined below that a couple of variables. And then I've got some code where I call these functions. Okay. So what's interesting is that in this first function add, we have a function called add. It takes two parameters, x and y. Okay. So when we reference the variables inside this function add, it's referring to the x and y that are passed in by the caller. Okay, even though we have an x and a y that are defined outside of the function, it's not going to use those because the ones that are inside the function are taking precedence. And that can be a little bit confusing. If maybe you think that you're actually accessing the x and the y that are defined down here, but in reality, it's passed in. And here we define x and y ourselves. So the value returned from this function, since we set x to 3 and y to 4, it's actually going to be 7. And it doesn't even matter in this case what values we pass in because we're overriding them or overwriting them. And it doesn't matter what x and y are outside of the function. So that tells you that the scope of this is the local x and y in the add function, not the outside one, which are usually called the variables defined in the file, not inside a function, are often called global variables because they can be accessed inside functions or outside of functions. So they're globally available. A variable defined inside a function is usually called a local variable because it can only be accessed inside that function. Okay, so let's look at the next function called add_2. That takes parameters a and b. So you'll notice inside the body of the function add2, it doesn't even reference those variables a and b. What it does reference is the variables x and y and the variable z that we've created inside the function. So we make a local variable z, but we're also able to access x and y from outside the function. So these global functions are accessible. Okay. So that's something to keep in mind. It's not something that you're going to do very often. You might do it in the final project, which is a bigger project. But for these small programs that we have, we generally won't do that. And we generally want to discourage the use of global variables. And that's because when we have a global variable, since anybody can change that variable, any function, it can be really confusing who's sort of in charge of it, in other words. So if it has a value, who set that value? right? It could be anyone, it could be any piece of code. So it gets hard to understand what's going on in a complicated program when you have globals. So often we want to avoid using them. All right, so that's probably a bit confusing. So let's go ahead and try some code here. Right, so we'll go ahead and do something similar. Just create some variables x and y. Make a function add, just to kind of avoid confusion of the names. Call that a and b, and we'll return x plus y to begin with. Okay. And then we will print the return value of our function, and it doesn't matter what numbers we pass to it, since we're actually not even using those. Let's go ahead and see what gets printed. Oops, got the wrong name. Let's try this again. So you can see it prints a 3 down here. So what's happening is it's printing the value of x, which is 1, and y, which is 2, which are defined outside of the function. And they don't have to be defined before the function either, just FYI. We'll get the same thing if we do it this way. So we still get a 3. Okay. So now let's return x plus y plus a plus b. So now we would expect x plus y is still 1 and 2, which is 3. A we're passing in is 3, so that's 6 plus 7 should be 13, or 6 plus 4 should be 10. And that's what we get. Okay, now let's try something else. Okay, let's make some variables inside the function. We'll have a variable, call it local x equals 10. Okay, now let's try to print local x. Well, we get a name error. It says local x is not defined. Well, it is defined, but inside the function. So it's only inside this function that we get access to local x. So the scope of local x is the add one function. Inside this function, we're free to reference it, use it. Whoops, wrong name. And so if we call this again, use those numbers, and we get 15. So if you add all these together, that's what you would get. So, I mean, the one way to look at it is you might say, well, why don't I just define all of my variables? Forget this. I will just define all of my variables outside of the function, because that seems like it might be easier to do. Well, you can do that. That's legal. Okay. But it's been proven from experience that if you do that, your code is going to get really, really complicated. I mean, it's not so bad when you have a couple of variables, but if you have 20 functions and 50 global variables, it very quickly becomes impossible to understand the code. Your code is also not reusable. Okay, so this function is only usable if you have variables of the correct name and you call it. So it's not something that you could just give to someone and say, okay, I have this library, it has a function called add. You pass it two variables as parameters and it will return the sum. Well, you can't do that, okay, because you'd have to define the variables outside of it and make sure that that function had access to those. So if that function was in a different module, it's not going to have access to the variables in your module. Okay, so that's another aspect of scope, is that variables in one module aren't accessible to another module, so another file. So if you have multiple files, you also have scope issues. Okay, so there are reasons for global variables, and occasionally you'll see them, but in general, you want to try to avoid it. Okay, so when I correct your homework, I may not necessarily take off points, but I'm going to make note of it that that's not the preferred way. If you start having module level variables instead of function level variables. Okay. All right, so that's as far as we're going to really dive into functions at this point. I did want to talk a bit about the Python standard library. So libraries are essentially sets of functions that you can use in your program that come with Python. And there are many, many, many libraries, probably hundreds, maybe even more than that. Some come with Python, some you can actually download from the internet that people have created and you can use. We've looked at one, which is the random library, which will allow you to generate random numbers. There's libraries to manipulate strings for date and time, for calendar, functions, math. OS stands for operating system. So if you need to do things with the underlying operating system, like dealing with files, let's say, you may use the OS, time, email, and many others. So I have a link here to the Python standard library. And as you can see, it's quite lengthy. So if you're writing a program and you need a particular function, it's a good idea to see if it already exists. Okay, instead of writing it yourself, it's a good idea to see if maybe it's already available. Someone else has already written it. It's already part of Python. So if that's the case, no sense you doing it yourself. Okay. Just to show that, I guess, why don't we, let's look at one of these libraries. Let's see, I don't even know what's in some of these, but let's say we import the time library, and we can use PyCharm to help tell us what's actually in here. Okay, so the time library has a bunch of functions related to time, and let's just see what time is. We'll print time.time, see what kind of a format this is. Okay, so this number is actually, it's not probably very useful in this format. It's probably the number of seconds in some arbitrary value. So you can take that number and you can convert it to today's, the exact time today to March 4th at 6:20 and whatever seconds. Okay. So in that format, it's not particularly useful. Clock. That's what that one does. Okay. Yeah, I'm not sure what that does either. It's not important. The point I'm trying to make is that to access a library, you import it, and then you access it by you type the name of the library, and then a dot, and then it will give you the functions. You can use any of the functions that are defined in the library. So here's one. I think this one, what this one does is delays your program by a certain amount of time. So This is one that is useful if you need to add a delay for some reason. You might need that, let's say, for a game or some other reason. All right, so I'm just going to print 1, and we're going to sleep for a second, because I believe that this number is the time in seconds, and then we're going to print 2, and we'll run it, and what should happen is it prints 1, it delays, and then 2, which is what happens. Let's make the delay longer so we can kind of see that. So it prints 1, it waits 5 seconds, then it prints 2, and then it exits. Okay, so that's just an example, and we can go in and look at the library and get the actual definition of all of these functions. So I'm just sort of guessing because I don't know all the functions in these libraries. There's just too many. But we could click on the time, for example, and that should bring up a page describing it, and we can get information about all of the functions and what they do and how to use them and all that. So that's what you'd want to do if you didn't know how to use a library. Okay. So I think what I'm going to do is I'm going to go through these in-class exercises from the notes, and then I'm going to do an exercise from the end of the chapter. And hopefully that will give you a good idea of how to write functions. Okay, so this says write a function called add3 that adds 3 numbers and returns the result. Okay, call this function from the same file that contains the function. Call it mymath.py. Okay, let's do that. Okay, so we need a function called add3. We'll say x, y, and z. It's very simple. We're just going to return the value x plus y plus z. And then what does it say? Save this file in a module called mypath.py. So do a save as mymath.py. Okay, so we've essentially created our own library here called mymath.py. We're going to create a new module, new Python file called main. Whoops. Let's name it something else. We'll create a new one called main math. Okay, so we have mainmath.py. We're going to import mymath. Okay, we don't need to say mymath.py, by the way, we just say mymath. Right, so now what does the instruction say? Import the module, call add3 from main.py. Okay. So we're going to say result equals mymath.add3. Okay, so we pass 3 numbers. Let's just say 1, 1, and 1. Obviously, the result of that is going to be 3. So if we print result, we run this. Okay, what did we do wrong here? Didn't see anything printed out. Okay. Return x plus y plus z. Oh, I know. This is, okay, we're going to admit the, got some joining the Zoom. So just wait a second, if you would. Hello, Patrick?
Hey,
How are you?
good. How are you?
I'm all right. So I've already started the session. What I'm doing is I am going through the notes. At the very end of the notes on functions is some exercises, in-class exercises. So I'm going to do that, and then I am going to do an exercise from chapter 5. So after that, feel free to ask any questions, or if you want me to do any other explanations for you, just jump in.
Cool.
Okay, so the reason that this didn't print what I thought it would is that we're not actually running mymath.py. So, or mainmath.py. So remember that the name here has to match the file that we want to run. Okay, so we need to run that file to get the configuration that matches up with the file. Okay. So now it prints 3 as we would expect, because if we imported mymath, and that has a function called add3, and that simply adds the 3 parameters, arguments that we passed in, returns it, and then we print it out, and that's what we get. All right, so continuing on here, we've done part 1 and 2. Now it says create a function called myPrint that has 3 parameters. The first is a value to be printed. The second one, called header, is a default parameter that contains header text. The third is a default parameter called footer that contains footer text, such as this. Test with different values for header and footer. Okay, so what we're going to do here is learn about default parameters. Okay, so I'm just going to, I'll use this file here, but we don't need to have that code. All right, so we're going to make a function called myPrint, and so myPrint just has some text. We'll call it str, and then something called a header, which is just some underlines, and then a footer. Okay. So because these are already have default values, we don't have to pass in anything when we call this function. Okay. Let's do the rest of the function. So we're going to print the header, and we're going to print the string, and we're going to print the footer. Now, in this case, in this function, we're not returning a value. Okay, we're doing something in the function, but we're not returning the value, any type of value. So if we call myPrint, and let's say it is March 4th. All right. So if we run this code, what happens is it prints these dashes, and then the message that we pass to the function, and then some more dashes. Okay, so notice that we didn't account for these parameters when we called the function, and that's because they already have values. Now, let's say that they don't have values. Now, if we try it, we're going to get an error because it says myPrint missing one required positional argument called header. Okay, so since it doesn't have a value, we have to supply it one. All right, so we could supply it with, something like that, and it's going to print that. But let's go back to the way it was. Okay, so the second time around, we want to supply our own header and footer. Okay, so we want to have, let's say, we want to have pluses, and I'll just cut and paste that so we have the same number of plus symbols. And if we call this, so we're overriding the default value that is defined in the function. Okay, so instead of the dashes, we're going to get pluses because we're passing in the plus strings. So if we print it, you can see what we get. We get the pluses. And this shows you how you can make a function that basically the caller can overwrite the default behavior of it. Okay, so you can set it up so that it works a certain way, but if the caller wants it to work differently, you can take advantage of the default parameter capability of Python to override that. Okay, so that's all for the notes. I guess before we get into any more examples, Patrick, is there anything you wanted to cover?
Yeah, I had a question, but I think it can wait until the end, probably.
Sure. Okay. All right, so I thought I would just pick out a problem from chapter 5. So I think I will do number 15, called test average and grade. So I'm going to create a new file here, new Python file, call it test average. Okay. This is number 15 from page 282. So what it says is write a program that asks the user to enter 5 test scores. It should display a letter grade for each score and the average test scores. Write the following functions. Calc average. This function should accept 5 test scores as arguments and returns the average of the scores. Determine grade should accept a test score as an argument and return a letter grade. Okay. All right, so instead of 5 scores, I'm just going to do 3, just make it a little bit easier. So we'll say score 1 equals, we'll assume that these could be floating point values, so there could be a decimal position. So we'll convert it to that, input what is grade 1. Assume grades from 0 to 100. Okay, so that's our grading scale. And we'll just repeat this. So score 1, 2, 3. All right, so when we run this, it'll ask us for the 3 scores. Okay, and that'll be from 0 to 100. And then it says create a function called calc average that accepts the scores and returns the average. Okay. Okay, so we'll call it S1, S2, and S3. We can name these anything we want. Okay, the names of parameters are totally arbitrary, right? Since it's called calc score, we can probably determine that these are the scores, right? But you can name them anything. And so all this is we're going to add the scores together. And this is a case where we need to make sure that we have the correct order of operations. We need to add them together and divide by 300, because if the maximum score is on each one is 100, then we need to divide by the possible total, which will give us the percent, right? So let's go ahead and make sure this part works. Let's do it this way. Average equals calc score, score 1, 2, and 3. And then we'll print the average. All right, let's see if this works. Well, first of all, we need to make sure we run this particular file. What is grade 1? Let's just say that the grade we type in 100. Well, let's say it's 75 for each one, just to make the math easy. So we have 0.75. Okay, that's the percent value. So we have to convert that back to, we have to multiply back by 100 in order to get the letter grade. Okay, but that seemed to work. 0.75 is what we'd expect, 75%, because each score was 75. So we've got the first function. The second one is determine grade, which takes the average and returns a letter grade. Okay. So the percent so we'll just make the values normalized to what is shown here. So if percent is greater than or equal to 90, then we return an A. Actually, yeah, that's right. If it's greater than or equal to 80, we return a B, etc. So I'm just going to go down and cut and paste this. So 80, 70, 60, otherwise. So if we don't hit any of those, we have an F, A, B, C, D, and F. Okay. So what should happen here is we convert the number so it's between a scale of 0 to 100. If it's greater than 90, that would be an A. If it's less than 90 but greater than 80, it's a B, etc. down the line. And if nothing else matches, then we have to assume it's an F. Okay. So we will say the letter score equals determine grade. We already have the average, and we'll print the letter score. All right, so let's run this and see what happens. Again, we'll just say each score is 80 for now, because we know that should be a B, and that's what we get. Let's try it again with different numbers. Let's say 60, 100, 83.2, and that averages out to B, which looks to be about right. Okay. Any questions on this, Patrick? Pretty straightforward. So what this shows us is that we could have done this without functions. Okay, we could have gotten rid of the function header and just made this code all line up in the file, and we could have done the same thing. But this is a lot nicer because it organizes it in a way that's easier to understand. Okay, because when we look in the code and we can say, oh, here's a function that calculates the score, here's another function that gets the letter grade, and then here's the other code that uses it. And we can reuse these functions as much as we want. Okay, so we can call them again from another point in the code. We could actually turn this file into its own module that we could save, and then for some other project, we could reuse it. Okay, so it's very handy to put code that might be used again into a function so that it can be reused by yourself or someone else in the future, so they don't have to write it again. So that's one of the main reasons that we like to split up our code into functions, and also objects and modules, which we'll talk about. At least the objects we'll talk about towards the end of the semester. All right, so if you have no questions about that, just let me know what you did want to talk about, Patrick, and we'll do that.
The one that I sent you, if I wanted to, so you said that I had to format the value in the function. Where would that be? Would it be after I write DEF?
Let me look at your question again. Just bear with me 1 second. Okay, so I think what you're asking me is so that instead of formatting it outside of the function, you do that inside the function and then return that value, correct?
Right. Yep.
So you would put your format statement before the return value, and then you'd this is what I would do. You'd say something like formatted value equals format miles, et cetera, and then return your formatted variable string. And then you can use that string however you like it outside of the function. Okay, so we can write something like that. Let's create a new file. Format.py, let's say. So we have a function called formatted string. Okay. Let's call it something else. Let's call it formatted add. So all this does is it adds 2 numbers and returns it formatted in a certain way. Okay, so let's say, so that's our result. Let's actually divide it just to make it so that the number is going to have more digits to it. Okay, so we want to format this. So it'd be something like this, and then the format string would be .2f. I think that's what you had. Okay, and then you can return the format string. Okay, so if we call this, and we'll say 1/3. Okay. Yeah, and we'll print the result. Yeah, let's see what we get here. Okay, so that prints the value that was returned. So if we didn't do this and we just returned the result, it's going to return it not formatted, and it's going to be this way, right? So if we format it inside the function, then that it's just that's sort of a design a decision that the programmer has to make if they want their function to already format it, or if they want it to not format it. If it's formatted in the function, then the user of the function doesn't have to do that. They don't, so that's convenient possibly for the user. But on the other hand, if the user wants to format it some other way, then they really can't because it's already done for them. Does that answer your question?
Yeah, it does.
Is that what you were getting at?
Yeah. that's exactly it. Thank you.
Okay. Okay. So what Patrick was asking, just if you're watching the video and wondering, is if there's a way to format the string inside the function so that it doesn't have to be done by who's ever calling the function. And yeah, so the way to do that would be you call the format function inside the function and you return that string that results from it. Okay, so we're going to return the format string. And then when we call this, it's already formatted. It's already in a nice 0.33. You know, you could format it however you like, but it's formatted for you by the function so that, you know, whoever calls your function doesn't have to do that. So, you know, it adds sort of a nice feature if, you know, that's what the user wants. So, okay, any other questions? Okay. Well, for those of you that are watching this later, because I know that many of you tend to watch these after the fact, if you have any further questions, just let me know, and I can either answer you or I can also make another short video if need be. Otherwise, we'll call this an evening, and I'll talk to you next time. Bye.